Homework 2.2, more on functions, video 2. Homework due Friday, May 22nd, 2020 at 11:59 p.m. In the previous video, we introduced the concept of a function being increasing, decreasing, or constant by describing the interval of x values over which the y values are increasing, decreasing, or remaining constant. I went ahead and set up another graph, but this time I want to do more than just answer the question, where is it increasing, decreasing, and constant? I want to give you the more rigorous definition on what makes a function increasing, decreasing, or constant. In math, and in a lot of sciences, and in some non-science areas, it's critical to be able to define things rigorously so that things that look like there's something are, and things that don't look like there's something aren't. For example, we need to define what it means to be increasing rigorously so that things that look like they're increasing are the only things that we say are increasing. So how do we do that? Well, let's start by finding the interval on which this graph is increasing. This function's graph is increasing, I should say. Well, from left to right, this graph starts out by decreasing and it's constant for a little bit. But on this third segment, it is increasing. And in fact, it's the only segment on which it is increasing. So let's start by identifying where this is increasing. What is the x value where this graph starts going up? 2. And what is the x value where the graph stops going up? 8. So we already know that this graph is increasing on the interval of x values 2, 8. And remember, we use parentheses instead of brackets because even though these points are on the graph, we don't say that the graph is increasing here. We say it's transitioning from something to increasing, nor do we say it's increasing here. We say it's transitioning from increasing to something else, in that case decreasing. But what does it literally mean in terms of x's and y's for a function to be increasing on an interval? Well, let's start the definition. A function f of x is increasing on an interval. Now, when you define things, you have to define them as generically as possible. So I am setting up a generic interval saying from a to b. Specifically, it's from 2 to 8 over here. Generically, we'll say from a to b. If a function is increasing on an interval a to b, if for any 2 x values, an element of the interval, and I've just realized that I'm using this symbol for the first time. This symbol, which kind of looks like an E, it's more of a Greek letter epsilon. But this symbol is a symbol for the phrase is an element of, which in set theory basically means 2 things inside of this interval. So for example, if I ask you for an element of this interval, I'm just asking you for a number between 2 and 8, like 3 or 4.7. So a function is increasing on an interval if for any 2 x values, we'll call them x1 and x2, in that interval, the first one being less than the second one implies something. Now what does that mean visually over here? Well, if we pick 2 x's and the first one is less than the second one, then the first x would have to be to the left of the second x. The word increasing is describing the y values. So let's think about the y values associated with both of these x values. Here's the first y value. And if I go up to the graph for the second one, let me scoot this x2 over a little bit. Where'd my x1 go? So here's my first x, which is less than my second x. Here's its y value. The second x's y value would be here. But how do you get a y value from a function? You insert the x value into the function. So the first y value is actually the function evaluated at the first x value, and the second y value is actually the function evaluated at the second x value. So if you're increasing, what can we say about these 2 y values? Which one has to be less than the other? If you're increasing, the first y value should be lower than the second y value. That's how come the graph is increasing. So a function is increasing if For any two x's that you pick in the interval, if the first one is less than the second one, then that implies that the first y value, which is the output of the first x value, is less than the second y value, which is the output of the second x value. It's a fancy way of saying the bigger the x, the bigger the y. If you're increasing, then the bigger the x value, the bigger its y value. So how would we define decreasing? Kind of the same way. Well, first let's look at this picture, which is kind of all marked up right now, but I think we can still see what we need. And let's describe where the graph is decreasing. Let's just go left to right. Well, that didn't take long. This graph is decreasing at the beginning. Well, in terms of x values, where does it start decreasing? At -5. And where does it end decreasing? At -2. So this graph is increasing on the interval -5 to -2, but that's not the only one. Notice it's also decreasing over here. So in some of these graphs, there will be multiple intervals where it is doing something. So how can we describe the x values on this portion of the graph where it's decreasing? Well, from left to right, what's the first point where it starts decreasing? Or rather, the first point's x value? 8. But where's the last point where it stops decreasing? Well, it never does. This will go forever to the right, and as it does, it will continue decreasing forever. So this will decrease starting at 8 and going on to infinity. But what does it mean in terms of x values and y values? I'm not going to rewrite the entire definition over there. I'm just going to focus on the key things that we need to change. Obviously, one thing we would need to change the word increasing to decreasing. And we're going to keep the fact that one x is less than the other. But when you're decreasing, the relationship between the outputs is different. So if we wanted to define decreasing, analogously to the way we defined increasing, we have to say what happens when one x is less than another. So we'll say the first x is less than the second x, but what does that imply about the y values, or what does that imply about the outputs? Well, we can just look over here and kind of see it. If we pick one x here and one x over here, so the lesser x, x1 to the left, the greater x, x2 to the right, and we compare their y values, which y value is greater, the first x's or the second x's? Well, if you're decreasing, it's the first x's. So the implication here is that if one x is smaller than the other, then that first x's y value, its output from the function, is greater than the second x's. So it's almost the same, the second x's output. So it's almost the same as this one, except the reverse, which kind of makes sense because we're talking about decreasing instead of increasing. So again, a function is decreasing on an interval if a smaller x produces a larger y. A function is increasing on an interval if a smaller x produces a smaller y. And I bet you can figure out how to define constant. I'll give you a hint. It starts the same way. We pick two x's in an interval. One of them must be smaller than the other. So we'll say the first x is less than the second x. But what does that imply about their y values, about their outputs? Well, if you're constant, the word constant means that the y values are all the same. So if you're constant, one x being less than another implies that their outputs are equal. So it's kind of a rigorous definition, but it makes sense if you think about it. If you're increasing, a smaller x will produce a smaller y. If you're decreasing, a smaller x will produce a bigger y. But if you're constant, a smaller x will produce the same y as a larger x. In terms of your homework, which by the way, you should try problems 1, 2, 3, and 4 after these two videos, all you really have to do is to be able to answer where is this graph increasing, where is it decreasing, where is it constant. So to close this video, let's answer the third part about where this graph is constant. In other words, where it's horizontal. That would be in this chunk in the middle. So from left to right, the x-coordinate where it starts being constant is -2, and the x-coordinate where it stops being constant is +2. So this is constant on the interval of -2 to 2. When you get to these homework assignments, these homework questions, you'll see that answering these are actually pretty easy. You don't even have to really grasp the definition, but, and this is something I should have said in the introductory video to this class, for several of you, this is the last math class you'll probably take, and that's okay. But for some of you, that's not the case. Some of you are taking this class because you may be heading towards pre-calculus, and then heading towards calculus 1, and then possibly calculus 2, calculus 3, and then more math classes beyond that. So every one of you, regardless of where your math path ends, are currently on a path that is heading towards calculus and beyond. As a consequence, I owe it to those students who are going to calculus and beyond to get into some of the more analytical and nitpicky definitions, such as what it means for a function to be increasing. Visually, the idea is pretty straightforward. Graphs going up, it's increasing. Graphs going down, it's decreasing. But as you go further and further down the calculus path, and you are on a calculus path, even if you're not going that far down it, as you go further down a calculus path, rigor and notation becomes critical. So when I do things like this, it's not just because I enjoy making the material harder than it has to be. It's because I know what's going to happen down the road for some of you, and I would be doing you a disservice if I didn't cover things like this. All right, so try out questions 1, 2, 3, and 4 in this homework. I think you'll find them quite easy.